So part 2 of the lesson from last day, unit analysis or dimensional analysis. And we're going to start out with metric prefixes. And in fact, we're going to start out with something that most of you probably do in your head, but we're going to say, what if I couldn't do it in my head? How do I do the math so that when we get to more difficult ones that we can't do in our head, we can do the math? As an example, "100 centimeters is how many meters?" Most of you know this. 1? Don't write this down. 200 centimeters is how many meters? 2? Okay. What are we really doing here? Here's my thinking, trying to come up with a power of 10 method to do this. I think what we're really doing with this 200 is we're multiplying it by a conversion factor. We're multiplying it by a conversion factor. I should put the units here, so let me put the units. 200 centimeters. I want to end up in meters, so I want that on the top. I want to get rid of centimeters. I want that on the bottom. What's the power of 10 on your formula sheet next to centi? 10 to the what? You always put that power of 10 next to the base unit, the one that doesn't have a prefix. So I'm not going to put it next to the one with the C in front of it. I put that there, and you put a 1 here. Because if you on your calculator go 200 times 10 and then hit your exponent button to the -2, most of your exponent buttons look like that, although some of you might have an X to the Y button. If you do that, you'll get 2. Because it says centimeter. Yeah, it says centi, right? We'll do a few more. Relax. And the reason I'm showing you this math trick is, although most of you can do centimeters to meters in your head, Tara, most of you can't necessarily do the yuckier ones. Here's what I mean. Pick up your pencils. 12, what's the capital M there stand for? Megagrams equals how many grams? If I wanted to do this mathematically, I would say this. They gave me 12 megagrams. I want the megagrams to cancel. Because originally megagrams is on the top, to get it to cancel, I'll put megagrams on the bottom. What units do I want left behind, Riley? So I want that on the top. Then I go hunting a conversion factor. I have no idea what the power of 10 that goes with mega is. 10 to the what? 10 to the 6th? So on my calculator, I would go like this. 12 times 10 to the power of 6. We're not doing scientific notation here, so I'm not going to use my scientific notation button. I'm actually just going to type in the equation, and I get an answer of 12 million, or I could write that in scientific notation. 1.2 times 10 to the 1, 2, 3, 4, 5, 6, 7. Let's do it in scientific notation. 1.2 times 10 to the 7th grams. Duick, this seems really complicated. Well, it is, except when you get to multi-step questions, this lets you build what we call a conversion chain. And this also cuts way down your memorization. So I'm going to try and sell you on this. Let's try example 2. Example 2 says 13.6. What's a lowercase m? From the chart? Milli. Okay. What do I want to end up in, Andrew? Amps. Thank you for remembering that A is amps from the very first day. And again, you don't need to worry about knowing that A stands for amps. What you have to be able to handle is the metric prefix. We want to go from milli to nothing, to the base unit, to the fundamental unit, to the no prefix. So how are we going to do that? Well, I would first of all write out the question with the units that they gave me. By writing out the question, I also feel better, more relaxed. And I'm going to multiply by a conversion factor. Zach, what units do I have on the top right now in the original question? So I want to get rid of those. Where am I going to put it to get rid of it? Because it's originally on the top, on the bottom. And that'll let me go to amps. What's the conversion factor for milli, Connor? 10. And that always goes next to the base unit, the one that doesn't have a prefix, so the one without the M or the C or the P or the whatever. Oh, I guess on my calculator, oh, by the way, down here there's technically a 1. Do I need to divide by the 1, Perry, or will that make a difference at all? I'll write it if you want, makes you happy, Tanisha, but I'm never going to actually type it on my calculator, okay? On my calculator, I'm going to type 13.6 times 10. You need to know where your exponent button is. If you don't know, ask me later or ask me now, to the negative 3, and I get, 13.6 milliamps is 0.0136 amps. 0.136 amps. Matt, that's a one-step question. Where this really starts to shine is in 2 or 3 or multi-step questions. So here's a 2-step question. In number 3, they're starting me out in kilo. They want me to end up where, Elijah? What's that funky symbol there stand for? Micro. Imagine me calling on you for micro. Go figure. They want me to go from kilo all year. Yes, all year long, my friend. They want me to go from kilo to micro. Now, here's the problem. I don't have an equation to go from kilo to micro, but what I can do is go from kilo to nothing and from nothing to micro. It's a 2-step. It's going to look like this. The first thing I'm going to do, AJ, is write down the question. 13.6. I'm going to go from AJ from here to nothing. I want to get rid of the kilograms. So in my first conversion factor, the way I'm going to get rid of the kilograms is I'm going to stick it on the bottom with just a grams on the top, with a nothing. I'm saying nothing. What I really mean is the base fundamental unit, grams. What's the conversion factor for kilo, AJ? 10 to the what? 10 to the 3? Now that's if I wanted to get to grams, but that's not what this question wants. AJ, what does this question want me to end up in? Micrograms. So I'm going to do another conversion factor. Other times. Right now, I've gotten rid of the kilos and I'm in grams. I want to get rid of the grams. Right now the grams is on top. Where do I want to put the grams in my next fraction? On the bottom. What do I want to be left with on top? Micrograms. AJ, 10 to the what for micro? Where is it going to go? Never next to the one with the prefix. It's not going to go next to the micro. It's always going to go next to the base unit. It's going to go on the bottom in this case. And in fact, on my calculator then, what I'm going to end up typing here, Curtis, is 13.6 times 10 to the 3 times 1 divided by 1. Am I going to worry about the ones at all, Curtis? Is that going to make any difference? It's going to be 13.6 times 10 to the 3 divided by, because that 10 to the negative 6 is on the bottom, 10 to the negative 6. Do you see it? Boom, boom, boom across. Divide, divide, divide the bottom. So get your calculators out, folks, and try it. 13.6 kilograms is how many micrograms? Let's see. 13.6 times 10 to the 3rd divided by 10 to the negative 6. Oh, I get an answer in scientific notation. I don't know if your calculator gives you an answer in scientific notation. Mine does. How do I read that, Amanda? 1.36 times 10 to the 10th power. That E on my calculator is a symbol for times 10 to the. You need to figure out how your calculator works. 1.36 times 10 to the, what was it, 10th? Micrograms. If you get the hang of this, you can get away with memorizing almost nothing. There are always some kids that try and memorize every single possible conversion factor out there. No, you can do everything with what you have on your yellow sheet and what you know up here.
I have 1.36 times 10 to the negative.
I think you typed it in wrong. So you went 13.6 times 10 to the 3rd divided by 10 to the negative 6?
Oh, negative 6.
Negative 6, right? Because that's the conversion factor. Let's try another one. This is so much nerdy fun. Actually, I hate this, but it's useful. We want to go from nanoliters to megaliters. I have no idea what the conversion factor is. I don't care. I can get there in 2 steps by multiplying, so I'm not going to memorize crap that I don't need. Dylan, you know how I'm going to start out? You know what the first thing I'm going to do is? Zach, what?
Write down the question.
With the units, because now I feel better. It's no longer late. No longer late? Wow, where'd that come from? No longer blank. Apparently, I was looking at Johnson. Yeah. It's a Freudian slip. You say one thing, but you mean a mother? Yeah. I write down the question. Do I have a way to go from nano to mega in 1 step? Nope, it's going to be 2 steps. So first I want to get rid of the nano. To get rid of the nano, Zach, where am I going to put the bottom? And then just plain old liters on the top. By the way, trick of the trade, when you're writing the liters, do the curvy written L, because if you write an L like that for liters, what are you going to think that is later on when you look at it? A 1. So, oh, and if you're taking physics and math, make your T's like that, because if you write a T, huh? Yeah, it looks like a plus sign if you just write a normal T. So curvy T's. And if you really, really want to go to the next level, I make my Z's like that, because if I don't put that slash there, mine look like 2's, because I'm a messy handwriter. What do you do for S's and 5's, Mr. Dewick? I'll almost never use an S as a variable, because mine all look like 5's. Hey, what's the 10 to the what for nano? -9. Where's it going to go? Sorry? Oh, yeah. You know what? Here's what I remember. Never next to the actual prefix. What I'm really saying is this. One of these is 10 to the -9 of those. That's what my chart's telling me. And this would get us, Perry, into liters, because the nanos would cancel. But do we want to stop in liters? No. We want to get to megaliters, which means we need to multiply by something one more time. This time, Zach, I want to get rid of the liters. It's going to go on the bottom in my next fraction. What's going to go on the top? Megaliters. I have no idea what mega is. Is it 10 to the 6th, I think? Yeah? I really haven't bothered memorizing these because I can use this trick to get to wherever I want to. Oh, I'll put a 1 down there just to make Tanisha happy. I'm not going to bother typing the ones on my calculator. It looks like the equation.
10 to the 6 on the bottom? Yeah.
Ah, Mr. Dewick, don't do that dumb mistake. I wish I'd done that on purpose to see if you were paying attention, and I didn't. Connor, you get a candy. Don't get used to it. So, Connor, what am I going to type? 2,000 times what? Divided by what? How did I know to divide? Oh, it's on the bottom, right? 2,000 times 10 to the power of -9. And if you probably want to try these on your calculator so you can interpret the answer, divided by 10 to the 6th. 2e -12. Oh, for me, that's 2 times 10 to the -12. And you want to make sure, because we looked last day, we spent lots of time playing with your calculators. Hopefully you remember how to go from scientific notation to floating decimal point on your particular calculator. 2 times 10 to the -12 megaliters. Is that okay? Try doing number 5 on your own. Go from kilo to milli. I'll do it up here. But see if you can get there on your own. Dylan, what's the first thing I'm going to do?
Write down.
Because now I feel better. It's no longer blank. I think that's right. Oh, I got a sheet right in front of me. Duh. There's a reason you didn't memorize these, Mr. Dewey. 10 to negative, yay, 10, yay. I think I'm going to write my answer in scientific notation, because that's a big number. That's what I got. See if you get the same thing. How many of you got that? Okay. Most of you? Few of you? Some of you? Some of you still working? Who's in chemistry? You'll be doing this in Chem too. If you wrap your brain around using conversion factors, A, the math, when you get the hang of it, isn't too bad. B, it really cuts down on your memorization. Let me give you an example. Part C says, multi-step conversions using conversion factors. How many seconds in 1 week? I don't know. I really don't. I might need to know, but I can figure it out. And I can figure it out using knowledge that I know just because I've grown up. Say what? Show you what I mean. They want me to go from weeks to seconds. Dylan, how am I going to start out? What's the first thing I'm going to do? 1 week. Do you know how many seconds are in 1 week? Because if you do, we're done. And maybe you do. Do you? What do you know how many of are in 1 week? Day? Okay, you know what? Let's go like this. Let's cancel weeks. Let's put it on the bottom. Let's put days on the top. How many days are in 1 week? You're saying 7 days is 1 week? See, we actually have that conversion factor memorized. We don't need a yellow chart on a formula sheet for that one. Now that would get rid of weeks. Now we're in days. Do you by chance know how many seconds are in 1 day, Dylan? I don't either. So what do we know in 1 day? We can go to hours. You all know 24 hours. And if you don't, oh, you'll grow. Okay. 24 hours, we can do that. So I'm going to go like this then. Connor, where are days right now? On the top? I want to put it on the bottom, and I'll put hours on the top. And you're telling me that 24 hours is 1 day? I agree. Oh, and that would get the days to cancel. Now we're in hours. Do you know how many seconds are in 1 hour? Now, this is where I actually do, because I've done it so often. It's 3,600. But if you don't, Connor, what do you know? I heard you say, oh. So let's get rid of hours on the bottom, minutes on the top, and you're telling me 60 minutes is 1 hour? And that would get rid of hours? Ah! And this one I do know. Perry, how many seconds are in 1 minute? See, that I can get, by building a chain of stuff that I know, I can get to whatever answer I need to. So let's cancel minutes, seconds, and you're telling me 1 minute is 60 seconds? And that would cancel the minutes. What's the math I'm going to do? I think I'm going to go, do I need to type the 1, Andrew? No. 7 times 24 times 60 times 60 divided by 1 divided by 1 divided by 1 divided. Well, I guess I don't need to divide by the 1. I guess it's going to be 7 times 24 times 60 times 60, which is what? 604,800. Anybody else? Check. It's Zach, so I want a second opinion. That's right. Oh, units? Seconds. About 500,000 seconds every week. How many hours in 1 year? I don't know. Number 7. But I think I can build a chain of conversion factors and get there. Let's see. How many hours in 1 year? Jordan, you know what I'm going to do first? How am I going to start this out? Have I started this out every other time? Dylan, how am I going to start this out? Ah, there, Captain Obvious. What? I'm going to write down the question. They want me to go from years to hours, so I'm going to write down 1. What would be a good abbreviation for years? Because I asked you to. What would be a good abbreviation for years? Why? Because I asked you to. What would be a good abbreviation for year? Why? I'll never get tired of that joke. I'll go, yeah, sure. Why? Do you know how many hours are in 1 year? Okay, what do you know of how many of what in 1 year? Ah, we can do that, no problem. So let's go like this. Let's put years on the bottom, days on the top. We're continuing from last lesson, last day. And we're going to go 1 year is 365 days. That one most of you memorized. Now, we are off technically. It's 365 and a quarter, although it's not quite that either, which is why we have a leap year. But every year that divides by 4, but also divides by 100 is not a leap year. So 2100 won't be a leap year. But every year that divides by 4 and divides by 100 and divides by 1,000 is a leap year, which is why 2000 was a leap year, even though it shouldn't have been. We have to tweak it a little bit because the decimal isn't exactly even, for what it's worth. I could see you totally cared. Okay, Jordan, we're in days. Do you know how many hours in 1 day? Oh, then let's do our conversion. Days on the bottom, hours on the top. You're telling me 24 and 1? Sure. $365 times 24 divided by 1 divided by... Oh, I'm not going to do the divided bys. $8,760. Units. Hours. You can even do this and have some nerdy math fun. Really? Yeah. Turn the page. Oh. Not going to get our nerdy math fun quite yet. How many seconds in 1 year? Anybody know? I did have one kid who had it memorized. Or they knew how many minutes were in 1 year because I think the musical Rent, there's a song that talks about it or something like that, and she knew it. Sorry? Yeah. So Haley Fiddler a few years ago, when I asked this question, she raised her hand and rattled it off. She also had pi memorized to 200 decimal places. She was pretty cool. Meanwhile, I haven't had a student like her since. Anybody know how many seconds are in 1 year?
How many hours are in a year?
Ah, we could jump back to that and go from hour. You know what? Why don't we? So let's go like this. 1 year, because we start out by writing out the question, Jordan. And you're telling me that I have a conversion factor that relates hours and years. Now, if I didn't, could I go from years to days to hours? 365, 24 hours? Yeah. But since we happen to just have done that on the previous question, let's get clever. What was it? It was 8,760? 8,760 hours is the same as 1 year. Times. Do you know how many seconds in an hour? Now, I told you 3,600, but you know what? Let's go like this. Hours to minutes. And we can get rid of minutes by going to seconds. Can you see, McKenna? I think I'm going to go 8,760 times 60 times 60 divided by 1 divided by 1 divided by... Are the divided by 1s going to make any kind of a difference at all? No. Okay, so 8,760 times 60 times 60. Or if you're really lazy, 8,760 times 60 squared. Which is less typing. Which is what I'm going to do. 31,536,000. Mr. Duick, why didn't you write that in scientific notation? Because no matter what, I was going to have to write the 3, the 1, the 5, the 3, and the 6. Adding 3 zeros or writing times 10 to that is about the same amount of work, so I didn't think I'd save any time by doing it. So I said to you, Callum, you can get away with memorizing a lot less if you have a conversion table handy. Here's a conversion table. This has some of the imperial stuff that they use in the U.S. because the U.S. still hasn't figured out the metric system. How many centimeters in 1 mile? No idea. And Sam, I couldn't possibly care less about trying to memorize this. Instead, what I'm going to do is I'm going to say, okay, they want me to go from miles, 1. I don't want to abbreviate miles with an M because that's meters, so how about we abbreviate miles with an MI? And then I'm going to go look on this chart and say, is there anything they've told me about miles anywhere? So here in this length section, have they given you any information about a mile? Yeah. Feet? Okay, you know what? I don't know where we're going, but let's go from miles to feet because it's a start. So I'm going to go like this, times, where am I going to put the miles, Michael? And the feet on the top, and, oh, 1 mile is 5,280 feet. By the way, do you notice as soon as we leave the metric system, it's no longer powers of 10, it's yucky numbers, which is one reason the metric system is so much more superior. You can do a lot of the math in your head if you're vaguely clever. Okay, we're in feet. Do I have anything that relates feet to centimeters? Don't think so. Fathom actually is a fathom. They use that to measure water depth. Do I have anything that relates feet to centimeters? Nope. Do I have anything that has centimeters there at all? What? Okay, so now, unfortunately, we have to ask if you've grown up and seen the U.S. enough. Do you happen to know how many feet or how many inches are in a foot? Most of you know that. It's not on the chart, but most of you know a foot is 12 inches. We have a conversion factor already, Tanisha, up here that we can pull out that they don't necessarily need to give me on a chart. I'm going to get rid of the feet, and I'm going to go to inches, and you're telling me that 12 inches is 1 foot, which it is. Now, do I have something that relates inches to centimeters? Yeah, there it is. 1 inch is 2.54. Okay. So I want to get rid of inches. I want centimeters to be left behind on top. And it says 1 inch is 2.54. Looks like I'm going to go 5,280 times 12 times 2.54. Do you get 160,934.4? 160,934.4 units, inches. No, centimeters, Mr. Duick, centimeters, centimeters. By the way, what do we measure our distances here in Canada when we come to talk about roads? How do we measure distance on roads? Matt, kilometers? How many meters in a kilometer? 1,000, a nice number. What do they measure distances in the U.S. in? Miles. How many feet in a mile? 5,280? Say what? Like you completely have to memorize an obscure, dumb number. It's not a nice round number. One more reason why the metric system is, to me, far superior. I mean, here's the other classic. Bushels and pecks and quarts. Right? To quote Calvin and Hobbes, I always thought a peck was a quick smooch. How the heck is it a measurement? Yeah. Number 10. 60 miles per hour in meters per second. You know what? Here we have to change two things. Miles to meters and hours to seconds. And can you see how I figured out what went with what? I said length goes with length, time goes with time. Jordan, can you tell me, oh pray tell, how I'm going to start this question out? Hey, that sounds like a great idea. 60 miles per hour. By the way, you'll notice I'm writing vertical fractions. Don't write fractions like this. Slanty ones diagonally, that's terrible. Hard to read. We'll do it sometimes at the very, very end for units, but never for actual numbers. Because now I can clearly see what's on the top and what's on the bottom. So I've got to do two things. I've got to go from miles to meters. I've got to go from hours to seconds. Nathan, which one do you want to do first? Doesn't matter. Hours? Okay. We'll take care of hours first. Now, this one's a little bit different. Nathan, where is hours originally, on the top or on the bottom? So to get it to cancel in my next fraction, where will I need to put hours? Yes. Okay. Do you know how many seconds are in 1 hour? You know what? Apparently you've just memorized that. Let's use that as our short. We could go minutes to hours again, but let's go, okay. And you're saying 1 hour is 3,600 seconds?
Yeah.
I agree with you. So this would be miles per second if they wanted me to go that far. We don't want miles per second. We want meters per second. So our next step, Tanisha, is we got to go from miles to meters. Do I have that anywhere up here? No. What's the only thing that I have up here for miles? Not nautical miles, but miles. You know what? I guess we're going to have to go for step one, because I don't know where I'm going to end up. I'm going to build my little chain here. Step one, Tanisha, is going to go from miles to feet. Where's miles on my original fraction, Tanisha? Top or bottom? So to get it to cancel, where do I put it in my conversion factor? Yep. And it's 5,200. What a stupid number. 81. Whoop. Somehow stuff vanished. Whoa. Somehow stuff really vanished. Okay. Right now, if we went 60 times 5,280 divided by 3,600, we would be in feet per second. We want to get to meters per second. Is there anything up there that relates feet to meters? Be nice. Is there? No? Okay. What can I go from feet to? Inches. Oh, let's do that. I don't know where I'm going, but I can do that. Feet's going to go on the bottom, inches on the top, 12 inches, 1 foot. Okay. Is there anything that goes from inches to meters? What was that I heard over here? We can get metric at least. We can go from inches to metric, and once we're in metric, then we're home free. So let's cancel out our inches, centimeters. Jake, Perry, what was the conversion factor? 2.54? Is that inches or centimeters? Oh, so 2.54 centimeters is 1 inch. And now we've come full circle to the very beginning of this lesson. I want to get rid of centi. I want to end up with meters. From my yellow sheet, centi is 10 to the what? 10 to the negative 2. Is that going to go next to the centi or next to the base units? From the yellow sheet, the metric prefixes always goes next to the base units. So apparently, if I want to go 60 miles an hour and change it to meters per second, I'm going to go 60 times 1. You know, can I stop saying the ones? Can we just ignore them? Okay. 60 times 5,280 times 12 times 2.54 times 10 to the negative 2 divided by 3,600. It's typing, but not a lot of work. 60 times 5,280 times 12 times 2.54 times, what was it, 10 to the negative 2 divided by 3,600. Do you get 26.824? Or am I wrong? Anyone else?
Yeah, I got that.
Got that too? Let's go 26.8. Round that, just for fun, round that off to 1 sig fig. 26.8 would actually be what to 1 sig fig? 30 meters per second. How many miles an hour did we start out with? If you're ever going from miles per hour to meters per second, it's roughly divide by 2. 60 miles an hour is roughly 30 meters a second. 30 miles an hour is roughly 15 meters a second. I started the lesson with the video on estimating numbers. That's a trick I use all the time when I'm in the US. Because from meters per second, I can go to kilometers per hour or do whatever I need to if I'm trying to figure out distances. You actually do math when you're driving? Shut up. Now turn the page. Let's have some fun. According to Wikipedia, although I haven't checked in the last 2 years, maybe there's been a bigger Powerball prize since then. When I first made this up 2 years ago, this was the largest ever lottery winnings. In 2002, Andrew J. Whitaker won $314,900,000. That's a chunk of change. What would you do? Because you never know. Well, you know what? The first question I thought of was, if I'm Andrew and I spend $1,000 a day, how long will it take me to spend the money? How many years will it take me to spend the money? Can I do that in my lifetime? Let's see. How can I figure that out? Yeah.
Is this before or after that?
Why don't you read part B?
Okay.
Thank you, Captain Obvious. Back to here now. Yeah. And yes, I thought of that and looked that up. Of course I had to, because I love the fact that you thought of the second question I thought of after this first question was, how much did he really take home? Yeah. Okay? All right. How can I find out how long it would take him? Well, first of all, let's take this money. Let's divide it by $1,000. That'll tell us how many days he has. So let's go 314,900,000 divided by, because he's spending $1,000 a day. How many days has he got? Well, 314,900 days. What do I want to change days into? Years. I need a conversion factor. Do I know how many days are in 1 year? Oh, so I don't need to build a long hopscotch chain? Great. Days is going to go on the bottom. Years on the top. 1 year is 365 days. Will he spend the money in his lifetime? Not even close. 863 years. Well, you know what? I heard Zach, why not spend town? Let's spend $5,000 a day. And let's look at the after-tax amount. Okay? So let's take this $114 million, and let's divide it by 5,000 to see how many days that is. 1, 2, 3, 4, 5, 6, divided by 1, 2, 3. 22,800 days. And let's multiply it by our conversion factor to go to years. Divided by 365. If he does that, will he spend the money in his lifetime? And I think the answer here is probably just barely be able to spend it in his lifetime. Although that's all. Yeah, am I wrong?
Do the days wrong because I typed it in and I got.
Do I have an extra 0? 1, 2, 3, 4, 6 zeros.
I got 91490 days.
You divided by 5,000?
No, it's the first part.
The first one?
Unless you can put up zeros. I got it from
Divided by 365. You're asking about this here?
Oh, I know, I did that the same thing as mine. Never mind. I got that number. I got 86.
So I think you left off a 0. Am I right? It is 800. I'm pretty sure the answer was nearly a millennium, almost 1,000 years of spending them. Now, of course, 500 years from now, $1,000 isn't going to be worth that much. There's that as well as, there's inflation and interest. It's a much more complicated question than this. But having said that, about 62.5 years. Numerous studies have shown, study after study after study has shown that people who win the lottery about 80% of them come to regret it and are far more miserable 2 years after winning than they were before. That won't stop any of you from buying lottery tickets, I'm sure. But for what it's worth, all it does is it proves, oh, everyone thinks they'll be the 20% exception. There's a saying, you've all heard it, money doesn't buy. It's true.
I just don't think I tell anyone I won the lottery. I just chill.
What's your homework? What's your homework? Everybody get a sheet? I didn't miss anybody? You didn't get a sheet? There's a weak link in the chain here. I won't mention her name, but she's awake now? Yes. Number 1, shirt. 2, shirt. 3, you know what? 3, I'm going to say do that column. And then on the next page, do I and J. You can skip A, C, E, and G. They're just powers of 10, which is kind of boring. Okay. Number 4, the mass of one electron is that much. What's the mass of... First of all, if that's how much one electron weighs, how much would 2 electrons weigh? What would you do with this number? How much would 5 electrons weigh? What would you do with this number? Riley, you're loud. Say it louder. Multiply by 5. How much would 10 electrons weigh? What would you do with this number? Multiply by 10. How much would that many electrons weigh? What would you do with that number? I'll let you think about it. I'm getting you to do some math with scientific notation. Get used to it. We're in the big leagues now. Velocity is light is that many. How much? So if the distance between the Earth and the Moon is that much there, how many seconds will it take light to travel? See if you can figure out number 5. If not, I'll help you with it. Blah, 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 blah. 7. Area of a circle is pi r squared. Please notice I gave you a diameter in number 7. How do I find a radius? I'll let you think about that. Unit conversions. This was what we need to practice. So number 1, 2, 3B, because I have a feeling Nathan has also wondered this question. What you really want to do is ask how many hours is 1 billion seconds, is really what the question is saying. 13, nah. 14A is tricky. Let's see if you can figure it out. It's got, you're going from minutes, the speed is in centimeters per second. I want the answer in kilometers. That's a tricky one. If you can't get that, I'll probably talk about it next class. I like number 15. Number 15, I've given you every conversion factor that you need in this question. So one of Mr. Camosi's ancient Italian ancestors was a chicken farmer who wished to purchase a wife. At the time, the going rate for a wife was 2 horses. 3 horses was worth 5 cows. 1 cow was worth 4 hogs. 3 hogs were worth 4 goats. 1 goat was worth 9 chickens. How much was it going to cost in chickens? In other words, what you really want to do is this. Convert 2 horses. How many chickens? See if you can figure it out by using all those different conversion factors. If not, I'll go over it in class. And then the last thing. So, Fermi problems. Enrico Fermi was a physicist who had often, I told you a little about Fermi. We watched the video. So here's a couple of Fermi problems. And these are bonus. You don't have to do these, but if you get a good answer, you'll get a candy. You can work with a partner or on your own. First question. If Pitt Meadow Secondary School has 1,100 students, you know what? Cross that out. Let's make it, we're actually at about 850. But let's go with 1,000, a nice round number, a Fermi number. How many pieces of note paper do you think the entire student body uses in 1 year? How much paper do we go through? And give me some kind of an argument as part. In other words, don't just say, I think the answer is 3,200,000. I want some kind of an argument. Give me your reasoning. Okay. Second one, how many flat tires do you think there are on the roads in Canada at any one time? And again, give me a backup, defend your argument, reason, convince me. Okay. That's your homework. Unfortunately, there's only about 7 minutes left. This lesson took a bit longer because I had to show you guys the video. I got to it with my other class. I don't see you block A. Well, I see you block E for a short little while. Now, last day I also gave you this sheet here called Homework Sheet A. Don't hand it in right now because I haven't had a chance to ask you for questions about it, but I've talked way too much this class. So when I see you next on Thursday, it's going to be, go to Pep Rally. When I see you next week on Tuesday, I'll take questions on all of these, okay?